Hello everyone, in this video let's discuss about the SR parser problem. If you are new to our channel, please subscribe for more engineering related topics. So if we see the theory part, SR parser will be using two data structures that are, first one is the stack and another one is input buffer. And there will be four actions. First one is shift, reduce, accept and error. So there will be two types of conflicts which will be arised in the SR parser, shift reduce and reduce reduce. While solving the problem, I will explain shift reduce and reduce conflict which will arise in the SR parser. They have given the problem and they have told that input string is id star id. So we must make three columns. First one is stack, second one is input buffer, third one is the actions. If you see in four actions, we will be selecting which actions to be done at that situation. Now the stack will be empty. Empty means we must write dollar. Dollar means the stack is empty. Next, at the input buffer, we will be writing the given input string id star id. With the id star id, that is the input string, we must add dollar. What dollar represent? Empty. My final goal is I must bring all the elements, that is the input string, towards the stack and make this input buffer as empty. That is, only dollar must be left at the end of the problem. So that is my goal. Now since my stack is empty, that is it is having dollar means it is empty. What I will do, I will shift one element this side. Which action I am doing? Shift action. So dollar will be as it is and id will be shifted to this side. What are the elements left? Star is left, id is left and dollar is left. You see id in the right hand side of the given equations. So in the right hand side. So in the right hand side it is separately given. That is, f is producing two projections. One is of E, another one is id. So f's separate projection is id. So I can replace f in place of id. Because f is producing id, no, so I can replace f in place of id. So to replace, we will be doing the reduce action. Shift action we did, we are doing reduce action. So reduce by f giving to id, because f is producing id, no, so what I will be doing, dollar, in place of id I will be writing f. Now star and id and dollar is left. Now I will see whether f is present in the right hand side separately. Yes, it is present in the right hand side separately. That is, t is producing f separately. What I must do? I must replace t in the place of f. So I must reduce again. So reduce by t give rise to f. So dollar t star id dollar is left. Now see whether t is present single-handedly in the right hand side. So it is present in the single-handedly in right hand side, but at this position I must not replace it with e, because it is the first projector. The first projector cannot be replaced until my input buffer is empty. Until my input buffer is empty, I cannot replace any element using this e. That is the first projector. That is, I can't replace the first projector until I make this input buffer as empty. So what we will do, we will make the shift action. So shift action is done here. Therefore dollar will be same, t will be same and this star will be shifted right here. So what will be left? id will be left, dollar is left. So what we did here, t was not replaced by e. So this is called as the shift reduce conflict, because we wanted to reduce in this position, but since it was the first projector, we did not replace it as the input buffer was not empty. So what we did, we shifted. So it is called as shift reduce conflict. Now let's proceed with the question. So t is there, star is there. You must see whether star is separately in the right hand side. No, it is not separately in the right hand side, it is in middle of this one. So I will see the combination of t and star. T and star is there, but with them E is also there, so I will not use. What I will do, I will shift again. So if I shift again, dollar will be same, T will be same, star will be same, ID will come this side. Only dollar is left. Now my input buffer is empty, because dollar is left means my input buffer is empty. Now if you see whether ID is present in the right hand side separately. Yes, it is present. It will be replaced by F. So reduce F producing ID. Now what will happen? Dollar T star ID will be replaced using F. So F will come here. Dollar will be as same as it is. T star F is my answer. So if you see T star F separately in the right hand side, it is there. We must see, because we must see the maximum possibility of finding the bigger answer. So T star F we are finding, T star F is here. It is produced by T. So what I will do, reduce T producing T star F. So now what will be my answer? Dollar T star F will be replaced by T only. So dollar is left. Now I must see in the right hand side whether T is present. So whether T is present. So T is here. Now I can replace it using E, because my input buffer is empty now. Since my input buffer is empty, I can replace it using E, that is the starting first projector. So therefore reduce E producing T. Therefore what will be my value? Dollar E. Here the dollar will be there. Since I made the first projector in this stack, since I implemented first projector in the stack, what will be my action? My action will be accept. My action will be accept. So we used only 3 actions: shift, reduce and accept in this problem. Until you make the input buffer as empty, you don't replace using the first projector. After making this input buffer empty, that is only dollar is left in it, then you can replace it using the first projector. Then you can solve the problem easily. At the last step, when you place the first projector into the stack, you can write it as the first projector into the stack and your input buffer is empty, then the action is accepted. Hope you understood the concept of SR parser. If you liked the problem, please subscribe and support us. Thank you.